So what we'll do at this point now is we'll write a function that incorporates all the changes that we made in our thing over here. And this is a very, very important step, though it sounds trivial. The reason is that you're going to be working with that data again and again and again. It's not like you take a piece of data and you sit down and you press a few buttons and write a couple of scripts and you produce nice reports and send them back there again. Data analysis is an art as well as a science. You'll be doing things repeatedly, looking at results and then trying to figure out why they don't make sense, then going back and doing them again, all that kind of stuff. And you don't want to go through all these data cleaning steps that we have in our we've done today. We don't want to go through them again and again and again. So what you want to do is you want to write a function that does that for you, and then you can call that function whenever you need it. So let's just walk through this very quickly and see what we did here. So our function says read 311 data. That's what we're going to call it here, and we give it a data file. We do our imports over here. This is an important step because you want functions to be independent. That means that they should be able to work. You shouldn't have to be importing stuff outside the function. So whatever imports you need inside a function, always keep them in the function. And in Python, it's not going to hurt you in any way. So you should do that. Then we have a fix zip, which is a function we wrote here. And notice we've included this function inside the function. It's packaged together. As far as we're concerned, we're going to use fix zip inside 311 data. So whenever we want to import data from the 311 site, and we could do this again and again and again, right? Because the data keeps changing every day. Then what we want to do is we want to make sure that fix zip is inside it. We might need to modify it at some point later, but for now we want to make sure we always include that. Then we've got that. Then we read the file, and we make sure we give the key there. We fix the zip by applying fix zip. Right? That's what we did next. We take out any rows that have nans, and notice that this is a little bit different from what I did earlier. So what I did earlier was that I was explicitly saying, hey, if you have a row that has a nan, if you have a created day that has a nan, or a closed day that has a nan, or a incident zip that has a nan, I was specifying those explicitly. Right? Now what I'm saying over here is that and Pandas provides a nice function called drop NA, and what that does is you can tell it, hey, go into my data frame, and any row that has a nan in any column should be dropped. Okay, there's options are how equals any and how equals all. So if you say how equals all, then it'll drop a row that has all nans, but keep rows that have one or two or three nans. And if you say any, if a row has even one nan in it in any of the columns, it'll drop it. So it's a convenient way of getting rid of nan data. So like I said, bearing in mind that we may not want to do that. Right? For example, if you're looking only at processing time, then we don't care if an incident zip is nan or not, if we have the complete created date and closed date. So you want to, this is a sort of a very it's like taking a hatchet to your data, but so you want to use it very carefully. Then we want to get rid of burrows that are unspecified, so we get rid of those. Any burrow that says unspecified, we get rid of it. We do the date time conversions and compute. So these are our date time conversions. This one creates created date, closed date, just what we did before, and then we compute the processing time over here. And once we got all that, we get rid of our negative processing times and return the completed data frame. Okay, so that's what we have here, and we can test this out. And by running it, oops, I should probably run that. We're still getting the error because this, or the warning, because we read it first and then drop this stuff. And once we do this, we are doing all our processing, which is why it's a little bit slower now, because it's creating the processing times, converting dates, which was kind of slow if you remember, and doing all that stuff. And we should see the result here, and we finally get this over here, and we have now a data frame that contains created data as date times, and closed data as date time, processing time as a time delta, and then everything else as either strings or floating point numbers.